Look at this. What is the polynomial for this graph? It's going to be lambda times lambda minus 1 times lambda minus 2 times. There is no confusion here. You know very well, 1 has taken a color and 3 has taken a different color. And 4 cannot take these two colors. So 4 has only the option of choosing lambda minus 2 colors. So it's into lambda minus 2. So lambda into lambda minus 1 into lambda minus 2 into lambda minus 2. And look at this graph. It's just a simple path graph. We know the answer for this. Lambda times lambda minus 1 times lambda minus 2, and of course a plus symbol here. Simplify this and then simplify this, you get this, and add these two things, you will get lambda to the 4 minus 4 lambda cube plus 6 lambda square minus 3 lambda. I did it quite fast. You can try to see how I arrived at this final form. Now let us take a back step and try to see what just happened here. Left hand side is equal to something on the right hand side plus something on the right hand side, right? I mean, C4 is equal to C4 with a diagonal plus a path. Now let me see something. What is this C4 with a diagonal? The chromatic polynomial of this is without diagonal, that is C4, correct? Minus, this goes on the left hand side, minus the chromatic polynomial of the path. So which means when you have a graph and you want to remove an edge, please observe very carefully. If you want to remove this edge connecting 1, 3, right? Chromatic polynomial of such a graph is chromatic polynomial of a graph without that edge minus the possibility when the chromatic polynomial of a graph when these two nodes become the same, which is here a path graph. So let me write that down neatly. Chromatic polynomial of a graph G is settle down on some edge and remove that edge. So it will be chromatic polynomial of a graph, the same graph G with that edge removed, correct? This is how I represent this with the edge removed, minus chromatic polynomial of the graph with that edge glued together. By making that edge vanish, what do? The vertices alongside the edge becomes one. These two vertices become one vertex. So chromatic polynomial of G is chromatic polynomial of G without that edge minus chromatic polynomial of the G, chromatic polynomial of the G with that edge. This is called coalescing. Okay, you fuse these two vertices alongside the edge. So now you see, let me put this in a square and tell you, I now have devised a way in which chromatic polynomial of a given graph is some difference of two chromatic polynomials of graphs which are smaller than this graph. Correct? We saw something like this in root polynomials, if you remember, but don't worry if you cannot connect that with this. All I'm saying is you can find the chromatic polynomial of a graph by seeing a chromatic polynomial of a smaller graph, right? So on and so forth. Now, it's time for us to see at least some 3 different problems in this direction and try to understand how to find the chromatic polynomial of a graph.